Okay, everybody, welcome back to our final session or before the closing. Um, it's my pleasure to introduce our speaker for our second keynote today. So, our speaker today is Dr. Saleema Amershi. She's a senior principal research manager at Microsoft Research, where she leads the Human AI Experiences HAX team, building tools for creating responsible AI experiences. She also co chairs Microsoft's Ether working group on human AI interaction and collaboration, which serves as Microsoft's advisory committee on responsible and ethical AI. Dr. Amershi holds a PhD in computer science and engineering from the Paul G. Allen School of Computer Science and Engineering at the University of Washington. And her work is extremely relevant to the topics that we've been talking about today. And my own area of interest is very much at the intersection of humans and AI. So I'm very excited for this keynote today. And as always, please, everybody, feel free to kind of bank your questions in the chat area if you think of them during the talk. And we'll make sure there's time for Q&A at the end. So without any further ado, Dr. Amershi, I hand over to you.
Thanks so much, Jane. And hi, everyone. I'm super happy to be here. As Jane said, I'm a senior principal research manager at Microsoft Research, where I manage the Human AI Experiences team. And I'm super excited to be here talking to this inaugural conference, Kane conference, about challenges and opportunities in responsible AI, much of which, in my experience, requires advances in our engineering practices and tools, even more so than advances in AI algorithms and models. And so that's what I'm going to be talking about today. So let's get started. Okay. So the first thing I often get asked when I talk about responsible AI is, why are we even so concerned about AI? Right? And after all, AI is ubiquitous. It's powering everything from our everyday applications to some of our most consequential services, like in our financial and healthcare industries. The problem is that while AI is enhancing our capabilities and improving our lives in many ways, as it extends further into our society, we're also starting to see more and more evidence of its potential to cause harm. And for this, I'd say, pick your headline. On the left here, we see facial recognition technology that was used to help blind and low vision people sense people in their environment. Whereas on the right, we see the same technology used in an undisclosed surveillance system by New York law enforcement officers who used it to find and harass a Black Lives Matter activist named Derek Ingram that you see here. Now, the problem here goes well beyond these sort of nefarious use cases like this. In fact, it's actually very easy for AI systems to go wrong, even in seemingly benign scenarios. So for example, some of you may recall Microsoft's Tay, which took less than 24 hours to turn from a friendly chatbot on Twitter to a sexist, genocidal neo-Nazi. And here, interestingly, Tay was actually doing what it was designed for, right? It was designed to learn from data and interacting with people. Except what we didn't anticipate was just how much of that data might be coming from trolls. So responsible AI, in my opinion, is really a movement that is demanding change and accountability across the industry. So here, for example, you see attorneys for Facebook, Twitter, and Google testifying at a Senate Intelligence Committee hearing on what they were doing to prevent the spread of misinformation and other Russian-led activities in the 2016 presidential elections. So this is great, responsible AI, it's important, this is needed, except what we're seeing is that the industry is not quite ready. So this is a survey of over 2,700 executives from organizations around the world who were using or deploying AI technologies. And what you can see here is that there's a big gap between concerns about AI, which is the blue bubbles on the right, and how prepared organizations believe they were or are to address responsible AI risks. So that's the teal dots on the left. Okay, so organizations said that while awareness of risks has increased, what hasn't increased enough is the adoption of actions to mitigate those risks, even by some of the most skilled adopters. So in the rest of this talk, what I'd like to do is deep dive into some of the forthcoming AI regulations and requirements, and discuss why it's still so difficult to actually implement them. And what I hope you'll see by the end of this talk is that achieving responsible AI will actually require both significant technical advances as well as significant cultural shifts in how the industry thinks about and approaches AI development. And then at the end, I'm going to speak also to some of the progress that we've already made in this space, as well as some of the open challenges where folks like you folks in this community can really help. Okay, so let's dive in. So responsible AI laws and recommendations are being proposed all around the world. And today I'm going to draw on some of these, focusing mostly on the European Commission's proposed AI Act, which is probably one of the most comprehensive and well-known sets of regulations. Now, it's important to note that most of these regulations that are coming out are still evolving, and many of them actually have open feedback periods that are happening even right now. And these are evolving because, as I said, we still don't know how to actually implement some of these regulations. So while I'm going to be showing you actual quotes from some of these regulations, what I show you may not be exactly what gets codified into law eventually. Okay, so this is one of the first requirements you'll see in the EU AI Act. And it says, for responsible AI development, it's important to anticipate risks. So this is actually a quote from Title III, Article 9, which says, the risk management system shall consist of a continuous iterative process run through the entire life cycle of an AI system, including for the identification and analysis of the known and foreseeable risks. Now, anticipating risks is important because, as you saw in my earlier example, it's very easy for things to go wrong. However, while it may be difficult to foresee what risks and failures may occur at any given time, you actually can and should plan for common types of AI failure scenarios, which is what this requirement is getting at. But what also makes foreseeing risks particularly hard in practice is misguided perceptions across the industry about what should even count as an AI risk or failure. So in fact, we recently did a study asking AI practitioners their perceptions about responsible AI incidents that you might hear about in the news. And we heard some interesting and even alarming things. So for example, when we asked AI creators about issues like Amazon's recruiting tool, which you see here, which showed a bias against women, a common sentiment that we heard is what we call the "this is reality" argument. And it goes something like this. There are a lot of people who do not see a problem with this. The attitude is, this is actually what reality looks like. Now, this is a dangerous sentiment because even if there is a gender imbalance in some fields like engineering and computer science, it's actually incorrect to say that AI models represent reality. Models, AI models, like all models, simplify the world. And that's because it's difficult, if not impossible, to ever fully capture all the complexities of the real world. So for example, in this AI-assisted hiring scenario, say your goal is to build a model to distinguish between people you should hire versus people you shouldn't hire. How you actually represent those people to your algorithm is important. So in this case, maybe you only have two types of information, the number of years of higher education a person might have and their previous salary. Okay, so in this simplified representation, you're not only missing a lot of important factors that impact whether or not someone will be a good candidate to hire, like their ability to collaborate or their real life experiences. Your choice of what information to use may encode biases themselves, like previous salary, for example, has been shown to propagate biases. So the point here is that this is not reality. And it's important to challenge this argument because it's this type of thinking that excuses the industry from acknowledging or taking steps to address the consequences of these types of issues. Now, another argument we often heard was what we call the "this is just math" argument, which goes something like this. At the end of the day, the data is just aggregated and shown. It's not going to be wrong what they're going to see. It's still going to be right. We're not expressing opinions or anything. Now, again, this is not true, and it's a dangerous sentiment because it lends a false sense of credibility to potentially harmful results. So, if we go back to our hiring scenario, AI algorithms, what they try to do is learn a model that generalizes well to new data while optimizing for some objective function, like minimizing loss on errors or errors on the training set. And so in doing so, they will actually trade off errors and sacrifice parts of the input space to produce the best function. So in this case, your algorithm first might try this model, which has 8 errors. And then it might explore and try this model, which ends up having 7 errors. So the point here is that, yes, this is math, but in this case, the math itself is actually allows for errors by design. And this is because, as I said, AI algorithms are designed to do the best under the circumstances. And because we can't fully capture the real world, they're going to need to allow for some errors. Okay, so AIs can make mistakes. So this first requirement for responsible AI of anticipating risks actually is difficult and requires shifting our mindsets and the mindsets of people who are building our AI systems to first acknowledge these risks. Now, say you or your team is building an AI system and you've acknowledged these risks, you've thought about some of the ways that things can go wrong. The EU Act also requires that you measure those risks. So it says that prior to placing on the market or putting into service, testing shall be made against preliminarily defined metrics to achieve an appropriate level of accuracy. Now, testing is important for any system, especially those that can have a real impact on people's lives. And in fact, many safety critical industries like transportation and medicine have rigorous standards in place to ensure acceptable levels of performance. In contrast, there's no such standards in AI, and I'd argue that it doesn't necessarily even make sense to create prescriptive standards. And that's because, if you recall my earlier example of the facial recognition systems, in the case of a police surveillance system, a false positive might be worse than a false negative, right? If you incorrectly identify someone and they get arrested, that's a problem. Whereas in the case of an assistive technology that uses facial recognition to sense people in your environment, in that case, a false negative might be worse than a false positive. So really, an appropriate level of accuracy is not well defined and is completely context dependent. What also makes measuring risks hard is that there's this deep-rooted culture in the industry around benchmark data sets and metrics, like what you see here in Kaggle competitions. And while benchmarks, data sets, and metrics have actually been really good for the industry, they've led to rapid advancements in AI algorithms and models because they allow for apples-to-apples comparisons. Bad things can happen when we over-optimize for them and use them inappropriately. So for example, take this incident where a Palestinian man was arrested when his Good Morning post in Arabic was translated to attack them in Hebrew. And this was using Facebook's AI-based translation feature. Now, we know from Facebook's communications that at least one of the ways that they were evaluating their translation system was using a metric called BLUE. And this is an industry standard that essentially counts the number of words shared across sentences without considering their meaning. But of course, preserving meaning was probably what was most important to optimize and test for in this incident. Now, while we don't know if this incident was entirely caused by this issue, our models and metrics not reflecting reality is a known issue, and it's one of the reasons why AI sometimes gets a bad rap. In fact, this graph shows the citation counts by year for common metrics used to evaluate natural language generation systems, like the translation feature we just saw. And what you can see here, these dashed vertical lines, is that these are major criticisms of these metrics over the years, criticisms about them not capturing reality. Whereas this blue line here is the number of citations for the blue metric in particular, which has only increased despite these major criticisms. And now this is not about blue, it's about a reliance on benchmark data sets and metrics that, while they might be efficient to compute, if they're not valid, meaning if they don't faithfully capture the real world, then measuring them to assess risk isn't very useful. So measuring risk really requires that the industry adopts more rigorous practices where we validate our metrics, validate that they're meaningful. Now, say your team recognizes that you can't apply standard metrics or data sets to test your system. What you might decide to do is then collect your own data for testing and training. And of course, there's regulations about data coming out because machine learning is often really a product of both an algorithm and data. And so what the AI Act says is that in order to be responsible, data training, validation, and testing data sets shall be relevant, representative, free of errors, and complete. Now, while this is well-intentioned, because, as the saying goes, garbage in, garbage out, it's also pretty much impossible because, as we already saw in the hiring scenario, all data has biases and limitations. And so I'd argue that it's actually better if we in the industry and community acknowledge that this is impossible so that we can take steps to minimize the consequences of the biases and limitations that are inherent in the data. Now, aside from that, what also makes collecting appropriate data hard in practice is that data is notoriously messy. And so, in fact, and depending on who you ask, AI practitioners and teams can spend anywhere from 45% to 80% to almost 100% of their time collecting data, preparing data, and processing. Now, some of these are probably exaggerations, but it's true that data wrangling is difficult and time-consuming. Data wrangling can include activities like collecting, preparing, processing, and annotating data. And each of these steps is tedious and error-prone in its own right. So, for example, take the task of annotating data. So with supervised machine learning, you need to annotate or label data to train a model to predict those labels on new data. Now, oftentimes labeling is done by human annotators, but people often disagree when labeling. So we see this often on subjective tasks like sentiment analysis. But interestingly, we also see reasonable disagreements on seemingly objective tasks, like, is this a cat? Right? Some of these images are probably, would agree, clearly cats, but some of these, a cartoon cat, a tiger, a picture of a cat, it's debatable. And in fact, we actually did a study several years ago where we had 9 machine learning experts label some tasks, some seemingly objective tasks like this. And we found that they were only 80% consistent with themselves on labeling the exact same data over 2 sessions. And about 6 out of 9 of those labels changed significantly. Okay, so, and this is just one step of this data wrangling process. So collecting data is challenging. Now, say, if you're creating an AI system, you've managed to do all that has been asked so far, you've anticipated risks, you've tried to measure them, you've collected some good quality data in order to test your system. The next requirement, according to the EU AI Act, is to mitigate risks. So the Act says, in identifying the most appropriate risk management measures, the following shall be ensured: elimination or reduction of risks as far as possible through adequate design and development. Now, why is this hard? Well, AI systems are complicated, and it's actually incredibly difficult to know which step in your typical model building process that you see here may have caused an error. Now, a lot of investment has actually been made in model evaluation metrics and tools. So, for example, we have tools to help you look at overall or disaggregate model performance, to visualize errors, to even help you identify or explain errors. But while these can help you form hypotheses about what might be causing any error, most of them don't help in actual mitigation. At most, some of these support model level mitigations like adjusting your objective functions for things like fairness constraints or perturbing different feature values to see what might change a model's prediction. But few of these tools take you beyond this and back to the data where a lot of the errors can actually be introduced in the first place. And therefore, mitigating and debugging errors that you might find is actually still really difficult. Okay, so now say you've done all your due diligence, you've thought about risks, you've measured them, you've collected good data for measurement, you've tried to mitigate any issues. Now, you'll still have some errors because errors are inherent in AI and machine learning. But that's okay because, after your system is deployed, you'll have a person there to oversee things, right? The problem is that, well, actually, one thing I really appreciate in the EU AI Act is that, and actually several of the forthcoming regulations, is that they acknowledge that people are actually pretty bad at this. And they acknowledge that if you want to have a person in the loop, there are many important things to consider to ensure that they can perform effective human oversight. So, for example, the EU AI Act says that to ensure effective human oversight, people must be able to fully understand the capacities and limitations of an AI system, remain aware of the possibility to automatically rely on it, to be able to correctly interpret the AI's output, to be able to decide not to use the AI or otherwise disregard, override, or reverse the output, or be able to intervene on the operation of the AI. Okay, now this is a lot of responsibility put on the human, and the problem is, and in reality, people are just really bad at this. So this is actually a real example where an Uber driver blindly followed his navigation app, which led him down some stairs. And now this is not even an isolated incident. It's actually a real phenomenon that's colloquially called the death by GPS phenomenon. And it refers to how people often over-rely on their AI systems. And this is due to cognitive biases like automation bias, automation complacency, having incorrect mental models, etc. And now, most of what we've tried in the industry to try to prevent these types of cognitive biases actually haven't really helped, or in some cases have made things worse. So, for example, there's a lot of work on AI explanations where, if you make the model makes a prediction or suggestion that shows you an explanation of why, turns out that often causes people to over-rely more on the AI system, even when it might be wrong. So this is still difficult. Okay, so putting a human in the loop is not enough to compensate for AI errors. So the point of discussing all of these is not to scare folks or, demoralize folks, it's a lot to do, a lot of requirements to implement, but we're actually making progress. And we can and should address some of these challenges. And so what I'd like to do next is briefly talk about some of the progress that we've been making and where I think we still need more help, especially from folks like in this community. Okay, so I'm going to draw on a study that we did a few years ago, which I think is still relevant today. So in the study, we surveyed 551 AI practitioners across Microsoft. And we did this to get a broad view of AI engineering challenges, but also to get a sense of some of the best practices that teams had implemented. What we found in this work was that this, in fact, was the typical end-to-end machine learning workflow. But note that this was a few years ago, even now, like before sort of large language models were introduced. So I would say this has slightly changed, but even with large language models, there's the training, data cleaning, data collection phase, and there's a lot of fine tuning on top of that and iteration. So still very iterative, and people are in the loop to try to evaluate and debug. So what we found was that across this typical workflow, the tooling is very fragmented. In fact, we found that teams reported that in most cases, the activities in this workflow were distributed across different tools, and sometimes even different teams. In fact, teams reported using over 135 unique tools across this workflow. Now, this is really problematic because it discourages good iteration and experimentation practices. So, for example, if you see an error in the model evaluation stage, it can be prohibitively expensive to experiment or try to mitigate those errors if you have to go back 5 to 10 tools to try something out. And you have to do that for each mitigation, right? So if you have to do that, go back several tools and then push your data back through the pipeline to see if it even helped, that can really discourage good practices. Now, likely what we found was that some of the most mature AI development teams had spent a lot of time streamlining this end-to-end workflow to encourage better practices. So for example, some of the teams reported that they built automated data extraction, processing, training, and deployment pipelines to make this process efficient. Others said, we focused on building a super solid data pipeline, which continuously loads and massages data. And that enables us to try different AI algorithms and different hyperparameters without much hassle. And that's good. And that's what's really needed to measure and mitigate responsible AI errors. But there's more that we need to do here. And I think what we also need to do is to stop sort of in the community thinking about each of these steps individually, and think really about these steps as an end-to-end pipeline. Because when we focus on individual steps and build tools and techniques to really, address that one particular step, we forget about the rest of the pipeline. And if you make any step too heavyweight, again, it becomes very expensive to actually iterate over this workflow. Now, we also found that some of the most mature AI teams paid a lot of attention to the data, so including on collecting, processing, and annotating data. We also found that mature teams made efforts to document and track data and model versions. So they said things like, we ensured complete traceability of all the training and test data, so we know exactly who reviewed or changed any label at any time. Another team said, each model is tagged with a provenance tag that explains which data it had been trained on and which version of the model. Okay, and so documenting and tracking and model versioning is important to support the sort of more rigorous and systematic testing and iteration. But currently, these tasks are still not very well supported by our AI development tools. Now, if you notice, I've talked very little today about AI algorithms. And that's not to say that, AI algorithms are not important. Advances are being made here with respect to responsible AI as well, such as work on privacy preserving machine learning or interpretable models. But a lot of responsible AI issues, I believe, really comes down to making thoughtful and good decisions. And that's because, in building your models, you always have to make trade-offs. For example, you have to make trade-offs often in choosing what to optimize for. And in fact, studies have shown that you can't actually achieve all your objectives at once. So for example, if you want to optimize for fairness, sometimes you have to sacrifice other responsible AI values like privacy. Okay, so these decisions come down to being thoughtful about your process. And we heard this from some of the most mature AI teams saying, you can be more relaxed about the framework and machine learning code, but be careful and deliberate about data and objectives. We also recently did a study to understand how different groups of people prioritize different responsible AI values. And we showed empirically that different groups, AI practitioners or representative samples of the population, prioritize values differently in different application scenarios. And so to achieve responsible AI, we not only have to improve our engineering tools and practices, we have to drive a cultural shift towards more deliberative and more human-centered practices. Okay. So today, I talked about what responsible AI is. It's a movement that is driving change in how we build our AI systems. And some of the forthcoming regulations around AI are going to require significant technical advances as well as cultural shifts to try to implement them. And we're making progress here, but there's much more to do, and we need your help. So I hope you take on some of these challenges, and I'm looking forward to hearing your questions. So thank you.
Okay, thank you very much, Saleema. That was a really interesting talk. So if anybody has questions, please either post them in the chat or come into the, just turn on your camera, turn on your speaker, and speak up and share your questions. Okay, so we have a first one already from Lewis.
I was trying to type it, but maybe it's better if I say it out loud.
That's much better, yeah.
Hi, Saleema. Thanks for the presentation. The keynote was excellent, and this is a very important topic, and I'm very interested on it, but maybe from a different perspective. And one thing that we hear a lot is the democratization of AI, in the sense that small players, small businesses are struggling to embrace this AI transition and to make sure that they also can be competitive. And what I see is that responsible AI is very important, but how do you see that these small players, how can they make sure that they are also doing responsible AI, but with the minimum amount of resources, because of course they are not Microsoft or Facebook or these big players that have all the resources to make sure that they can actually do something about it?
Yeah, this is a great question, and it's super important. It is what regulators are thinking about as well. So this is why there's a lot of feedback. So for example, the EU AI Act, there's feedback, I think, from at least like 500 organizations, big and small, about some of the different challenges that they might face in implementing them. So I do think that it is something that we need to pay attention to. Many of these regulations distinguish between developers, organizations that may build a lot of the models, and deployers who might ingest some of those models and use them to drive applications. So that's one scenario that you might see in a small business. And then the goal is to sort of distribute responsibility across those organizations. So there might be some of the work being done on the model development side, and then some of the work on testing and under operational conditions that might happen more on the deployer side. But it's definitely a concern, and I think this is another reason why it's important that we build tools to streamline some of this, because right now it's really, it's an art, it's a lot of manual work. You have to have a lot of training to sort of understand all the knobs that you can play with, the trade-offs that you can make. So it is a really high bar, but it's important. So I think this is where we need to come in and help. Those are great questions. Thank you for asking.
Thanks.
Great, thank you. I think Christian has a question now. Oh, he just coming back.
Can you hear me?
Yeah, you're here.
Thanks for the great talk. I really appreciate this. A lot of what you talked about is very model-centric. It's about how we be more responsible in building models or building the pipelines that are building models. But what about the rest of the system? There's often a lot of non-machine learning code, right? Safety issues really happen from the system interacting poorly with the world, right? There's a lot of safeguards outside the model. How are you thinking about that, and where should responsibilities lie there?
Yes, definitely. This was quite a model-centric view. I myself have worked mostly on the human AI interaction side of things, so I do think about the different aspects of the system, and I think this is actually another one of those cultural shifts that have to happen. And this is a sort of diagram that I like to show where, for one, an AI system is much more than the model. Right, the model is one piece. There's the data, there's the interface, there's the infrastructure, and for sort of taking a more human-centered approach, which is what I think we need to do, it really starts with understanding the people and context that you're going to work with, doing the sort of user research that you might need to drive all of those decisions for the rest of the system. And I think this is what we need to encourage more, because even if your model is correct, say it is, which it won't be, it's impossible, but interfaces really play an important role in how people interact, how people can use these things responsibly. So I think I talked a little bit about explanations, and there's been studies that show that even just like the length of an explanation can cause people to over rely on an AI system more, even when it's wrong. And so I definitely think that there's much more to be done on all of these pieces. And in fact, I would say that one of the most difficult challenges is that the sort of boundaries across these different systems are breaking down when it comes to AI. We have to come up with, ways to collaborate more effectively, create boundary objects between different teams that might be working on, design versus the data science, to really be able to experiment and iterate and build these systems more and think about them more holistically. So I 100% agree. Thank you.
Thanks.
Great, thank you. I think Jinghua has a question.
Thanks, Saleema. Very interesting talk. So I just have a question about ethical risk assessment or measurement. So you mentioned we need to identify some metrics for ethical risk assessment. I just wonder how you measure the likelihood and the consequence for some of the principles, which might be difficult to validate in a quantitative way. So do you have any suggestions on that?
Yeah, I think
how to avoid subjective view when you do the measurement.
Yeah, yes, it's definitely challenging. I mean, there is subjectivity in terms of what you decide to optimize for, but there are metrics being introduced to try to optimize for some different ethical values. So for example, there's a lot of work in fairness related metrics where you'll try to achieve parity across different demographic groups, right? So you look at breakdowns between groups and determine whether or not there's a disparity in how their model performs across those groups, and then maybe try to mitigate those disparities. But even that, there's subjectivity in there, right? Because which groups do you focus on, right? So I think it's a difficult question, and then there's more to be done there. I think we can learn a lot from measurement modeling work, where there's a lot of thinking around validation and different types of validity, construct validity, structural validity, where we can try to validate that our models are reflecting what people actually need and want in the real world, to try to reduce some of that subjectivity. But it's really hard to eliminate entirely when it comes to ethical principles.
Yeah, thanks. Thank you.
Great, thank you. Okay, we don't have any other questions lined up, so I'm going to get to ask my question. I was wondering, you kind of basically started by talking about the European Commission's proposed AI Act, which is actually really interesting, and I wasn't aware of it, so that was really nice to see that. But I'm kind of thinking about accountability. So let's say you're building a system and you go and think through all of those things. Where do you think an organization, to what degree of accountability should they be held for the AI systems that they build? Should it be a kind of a case, like a safety case, or should it? What do you think that should look like?
Yeah, I mean, this is, I think, the key question that people are trying to answer. I think, for one, I believe errors are inherent in AI systems, and it's impossible to eliminate them entirely. But we have to be doing our due diligence to reduce those, and also give the people who are ultimately using or affected by those systems safeguards, right? So ways to either override, intervene, or challenge some of the decisions of those AI systems. So I think that's part of the accountability, right? Like, the people who are developing and deploying not only have to do their due diligence, but they have to ensure that people in society can do their job appropriately. So I think it's a really difficult question, and I don't think we know the answer. My guess is it'll be sort of case by case basis until we figure out what is feasible, what is the bar that we must achieve to make sure that our systems are safe, fair, reliable, responsible.
Okay, great, thank you. If anyone has any last questions, we just have a few minutes. So if you have a question, please type quickly or jump into the room. Otherwise, you'll run out of time. And I'm going to ask one more question. So as Christian mentioned, this you talked a lot about pipelines and things like that. I'm kind of wondering, from your group in Microsoft, do you have any plans to kind of create tools that we can use? Is this kind of is it really more for your kind of internal consumption, or is that part of your plan that you'll kind of be putting things out there for others to use, and what might those look like?
Yeah, this is a great question. I would say both. We're definitely working on tools that our own teams can use to make their processes more streamlined and efficient. But a lot of those tools we put out in the world. So we have a lot of error assessment tools that are available open source. So the Responsible AI Toolbox for example, is open source set of tools for error analysis. Fair Learn is in there, Interpret ML. So those are tools that everyone can start using to on their AI systems. We also, my team, for example, works a lot on human AI interaction and experiences. So we have the HAX toolkit, which is the Human AI Experiences Toolkit, which has a set of tools to support interdisciplinary collaboration and sort of guide you through thinking through some of these responsible AI risks and challenges. So that's something we use internally, but also it's available for people to use. So I think it's going to be both. As Microsoft, we also build a lot of services, right? AI services. And so those are, when I was talking about the developer versus deployer distinction, sometimes that's, we pay a lot of attention to those models that might be reused. Like, how can we test those, provide clear documentation so others can ingest them and use them effectively? And what guidance can we give those other companies that might build upon those models?
Okay, great. And Jan, are you jumping in because of the next session, or he's gone? Okay, I was thinking I might have time for one question.
I'm here. I'm
here.
here.
Do you have a question, or are you just here for the next session?
No, I was listening into the keynote by Saleema. Thank you very much, Saleema. That was really wonderful. I had a question, Jen, if you allow me.
Yes. Okay. Last question then. Yeah.
Oh, well, I mean, one of many of the examples, Saleema, that you used were focused on human-oriented online systems, so to say. Mm-hmm. Quite a few of the companies that I work with are concerned with embedded systems, for instance, autonomous drive and those kind of questions. Could you, from your perspective, share how to think about these kind of questions when we talk about autonomous systems like self-driving cars, self-driving trucks, autonomous mining equipment, those kind of systems? how does this apply to that industry in your view?
Yeah, well, definitely in a lot of these cases, even with autonomous vehicles, for example, like in most cases they're semi-autonomous, right? There's still a requirement to have a person there. But I do think that we are moving to more, fully autonomous. And then I think the thing to think about is the different stakeholders that might be affected, even if there's not a person interacting, right? So there's still like the similar decisions you have to make in terms of like what you optimize for, what you test. How does false positives versus false negatives like affect the people, even if they're not interacting, right? So an autonomous vehicle, like, if you miss an object on the road, like you're making a decision when you're building that AI system about like what types of errors to optimize for. So I think a lot of the same questions come into play. But I think, I think it's a good question, especially, one thing I sort of talked about very simplified systems, but really most AI systems are several different models like working together, right? And so really, errors propagate, and fixing some error in some model can actually make the overall system worse, right? So I think there's a lot more that else still needs to be done when you're, bringing all these models together to drive, a fully autonomous system. So just more work that needs to be done in tooling to support that.
Yeah, so I mean, if you allow me to expand a little bit on the question, even though we're out of time, so Jane, stop me anytime. We're seeing in automotive that level 4 autonomous drive, which means on the highway, the car drives itself. That's becoming a reality within the coming 12 months, if it isn't already there, depending on the brand. And then you run into the situation that companies have to go to quite significant safety assessment, of course, which is a responsible and reliable AI mechanism, because then you have to collect the data that system is actually safe. Do you feel that that's sufficient, or are there then still things that are missing from your view that we need to address within that part of the community?
Yeah, that's a good question. I mean, testing is critical. I think there needs to be some thinking about who is doing the testing. Is it the organizations building those systems? Is it independent auditors? What is the role of like third parties who need to be doing testing? And whether or not there needs to be some standards in place like we have for other industries. So I mean, definitely like testing is one of those things. I think another is being able to fall back or revert. So a lot of these systems, you'll train these models, but then you'll update them, right? Like as you learn more, as you fix things. And so we need ways to efficiently test and retest, but also when things go wrong, when you change things, how can we, build infrastructure to make reverting and even fixing things much more efficient, so we can deploy, right?
Yeah, great. Thank you very much. And I'll leave the floor because I think Jane wants to close the session.
Oh, you can stay on if you want anyway. But well, thank you. That was such an interesting talk, and I wish we had a little bit longer to ask you even more questions. But thank you. It's very thought-provoking, and thank you very much. So let's all give a round of applause, and thanks to Saleema.
Thank you.
Okay, thank you very much. And with that, I'm actually going to hand back to Jan. So, and I think Tom should come.
Yes, and the challenge is that officially our closing session will only start at 6:15. So the question is, do we take a 15-minute break, or do we take, or do we start the closing session right now?
We could have asked more questions. I was trying to go. I had more questions. Sorry.
No, that's perfectly all right. But I think that. So how do you want to do it, Jane? Do you want to keep the discussion with the keynote speaker open, or shall we move towards the
sorry, I got
session
wrong on that one. If Saleema wants to come back in, if anyone has any other questions, otherwise, I think we should. So apparently I cut you off early, and whoops.
Oh.
If you do have a few minutes, we may have some more questions, and we could just keep going a little bit longer. If
Yeah,
that's
sure.
okay.
Happy to hang out for a few more minutes.
Okay. So I did actually have a question, and so that's why I particularly wanted to call you back, seeing as I realized my mistake with the timing. So you had mentioned about, I think it was the you call it TAY, the TAY app, where the system learned, to be kind of rude or not treat people well. And so I think when I was thinking about that, that kind of brings up the whole idea of evolving systems and how the, for example, the the qualities that we look for in a system. I mean, at that point, I think what Microsoft did is just withdraw the whole application. But would there have been other? Would it be something that? I mean, obviously there was kind of a whole, look of what had gone wrong, but would there have been a way to have evolved it and learn from that mistake rather than throw it away?
Yeah, well, I think definitely what should have been done more is put in some safeguards before deployment, right? So once it's like trained and learned, then it's hard to sort of revert. But if we put in potentially like safeguards against like feeding in some of the data that might have been that people were saying when they were interacting with it, maybe limiting how what is used for retraining, that would have been step one. And also, controlling sort of like how quickly it might evolve would have been another. But yes, I think then like, there's possibly, so one thing, if we think of the end-to-end pipeline, one thing I think we need to encourage more is starting small, right? So starting with like really simple models, even rule-based models to test the end-to-end pipeline, but also test the system end-to-end. And that way, for one, we don't invest a lot in models that might not work well, like complex models that might be take a lot of resources to build and are harder to change. What that also does is that allows us to revert more easily, right? So maybe, if we had deployed this, we see it's, gone astray, we could easily revert to a previous version or even a simplified model, still having it interact with people maybe in a more limited capacity while we fix things. So I think it's partly, putting in safeguards before you deploy, but then also making that process of updating and reverting more efficient.
Yeah, I guess that, these lessons learned will eventually kind of get back into, I don't want to call them regulations, but like the act and, because I think that those are important lessons learned because you can afford to let things learn and run their course when it's not in the public domain, when it's doing the learning, I guess.
Yes, exactly. Yeah. So I think, we are learning. It's, it's a rapidly evolving space. And we're, it's about, like I said, doing, your due diligence and being deliberate and intentional about choices, and anticipating the possible failures. And that's something I think we also don't do enough of is, just thinking about the common failure scenarios. Because once you start doing that, then you can, cross that with the stakeholders and then estimate costs, right? Do your impact assessment, which is something that, we tend to be tech first and deploy things, whereas like the sort of more human-centered approach is to think about consequences and then make decisions that way.
Okay, so if anybody has any other questions, if Saleema's okay to stay for a few minutes, we still do have a few minutes. And otherwise, I'm going to, in the meanwhile, one of the things we've been looking at, which I think is kind of interesting and fits in here, because your interests are in kind of humans and AI, and building on Jan's question about autonomous systems, which is the area that we're working in. One we've seen that a lot of the examples of where humans are engaging in AI are not actually, they're either in autonomous systems where it's kind of human on the loop, or they're in decision-making kind of AI systems. But one of the things we have kind of seen when you try and have humans and machines work together is the very different cadence at which humans and machines can make decisions. I don't know if you thought about kind of that aspect of it and have any thoughts about that.
Yeah, I think this is a great question. One of the things we are thinking a lot about on my team is, human AI teams, so teaming scenarios and the different ways you can implement those, right? So then often, we think of these sort of simplified decision-making systems where every decision is overseen by a human, but that's not always the case, especially for these autonomous systems where really they're making, many, many decisions rapidly, right? The other thing that we've seen is that a lot of the work on, for example, explanations, you see that putting a human in the loop can often be worse. The performance of the team when a human is in the loop can often be worse than the AI or the human alone, right? So I almost think that, we have to rethink, this approach of having a human oversee every decision, maybe leverage the efficiency of AI systems on some data. But then, if we do that and we sort of do more delegation, right? So maybe we delegate some of the tasks to an AI and then some of the harder tasks, for example, to a human. That's one way, instead of having sort of every decision being overseen. But I think if we do that, then we can also put in additional layers, right? We can think about, well, instead of a human overseeing and adding a sort of burden of a human overseeing every decision, leverage the ability of the system to make some automated decisions, but then put in extra layers of review over those decisions, right? So I think we can think creatively about and put in safeguards, have review systems that aren't sort of at the point where the decision is being made.
Kind of like retrospectively, like it's made a decision, you want to kind of, check that it was right and maybe kind of a system if it's making wrong decisions.
Yeah, for example, we're doing, there's these large language models being used for code generation, right? And so right now, you have code generation models and humans sort of overseeing each generation and editing. But, the over-reliance and automation bias is real, it's something that's hard to avoid. So one way is, to try to mitigate that is take the advantage of the capabilities of the AI, but then put in, enforce more, code reviews, or, tag, these types of generations so that they can be double checked, at a later stage, but still you get those sort of efficiency gains. So I think that, thinking more about sort of different paradigms of interaction and teamwork, I think is going to be important.
Okay, great, thank you. And I'm just going to close with one question, and I promise this is the real close this time. Do you see in the US kind of landscape as well, or in other countries, we've talked about the European Commission. Do you see that this is emerging in other countries as well? I mean, obviously we're in the US, so I'm going to ask for that. And many of our people are either attendees either in North America or in Europe, and a few from other countries. But do you see this as a kind of international effort?
Yeah, definitely. I mean, definitely they see regulations coming up all over the world. And it's interesting to see because there's some commonalities, but then there's also some cultural differences in how these are written up. So it'll be interesting to see sort of what different countries converge on and what sort of society converges on. But definitely regulations are popping up across the world.
Okay, well, with that, thank you. It was really a great talk, as we mentioned before. Thank Saleema again, and really appreciate the time that you gave us to talk with us today. Thank you.
Thank you very much. Also on my behalf, Saleema, this was really wonderful. And that means that we are now moving into the closing session. I will start to